Hey, object-oriented programming is good. Asterisk.
A few years ago, I made some videos laying out a case against object-oriented programming, and since then I've been meaning to make a positive case for an alternative, a prescription for how code should be written rather than how it shouldn't. It's taken me a while to work out what I think can be said about how to write code with any certainty, and confusingly the prescription in part might sound suspiciously like OO to some ears. I'm not really recanting my prior position though. Many people just remain confused about what's unique to OO and what's not. Hence, I'm calling this object-oriented programming as good, but with an asterisk.
That was a very long asterisk. Okay. Okay, so we have an OO hater that might be coming around to enjoying a little casual OO. Is this some casual OO? Is that what we're seeing right now? Could be. Could be kind of a little bit cash, you know? Just a little OO hater turned lover, you know what I mean?
A more honest title for this video might be Module-Oriented Programming, where module refers to a unit of reasonably self-contained code, but the even more honest title would be How to Write Good Procedural Code.
I love it. Dude, procedural code is the best code. Fight me. Fight me. It is the best, okay? It is the way to do it. There is no other way. Procedural code is just always been, it will always be, it has always been. Functional programming is just procedural code with functions. Change my mind.
Encapsulation, polymorphism, and even inheritance will be a part of the story, but as I'll explain, the total picture has profound differences from object-oriented programming. So here's how I think code should be written. Code should be written in units we'll call modules, and these modules come in two basic kinds: state modules and logic modules. The distinction is that logic modules contain no internal state, i.e. global variables, and logic modules do not reach out for external state.
Starting to sound a bit functional right here. I'm just saying already, we can tell just right away, this sounds like pure functions going on right now. Tell me this is not some pure functions right now. Tell me this is not it right here, right now. Interesting. So this thing only contains external state. So when I see this, what I think is that these are like definitions, structs and stuff. This is implementation on the structs, traits, whatever you want to call them. It does all that. Define a pure function without using pure. A function with whom has no side effects. Laughs, instructs, and impl. Exactly.
This means that a logic module consists only of functions, and these functions only touch stateful things which are explicitly passed to them. So a logic function can, for example, read and write to a file if an open file is passed into the function, but a logic function cannot itself open any files.
I'd say that in general, that's just building good software. I think I see, because he did talk about just like how to build better software. You should always avoid certain activities within a file, right? Like if you want to do something to a file, such as take a file, like open a file, read out the contents, go over the JSON blob, parse out whatever X events, sum up some values, do something like that. What I tend to find is a lot better is separate out those into two separate ones, right? The file bits and then the actual like logic bits, because that way you just pass in, say, your events, whatever those events look like, and then it does the operation on top of it, because it just all, like whenever you separate out things like that, it makes testing easier. It just seems to make logic easier. It just makes your life easier. I feel like that's usually a good sign of a more junior person, is that they mix all them logics up.
The management of state is not the responsibility of logic code. A logic function may generate new data and also may mutate its inputs, but its only responsibility is to generate and mutate data only as it says it will in its documentation. The side effects of a logic...
Ooh, I'll do that. We'll pull. Let's pull. All right, here we go. Let's pull. Are you ready? All right, new pull. OOP? OOP? Do you like OO? Yes or no? Yes? No. Do you like OO? Tell me right now. Okay, here, let's start the poll. We got to know. I just got to know. Where's the poll? It's right here. Oh, we have a pretty... I'm actually pretty shocked. We have a pretty split group here. I honestly did not see this one coming. I really, truly... Dynamic dispatch is a curse. Yes equals actually no. Oh my goodness. I think you're trolling me at this point just to get him to tie. What? There's no way that more people like it. There's no way. There's no way. What? Okay, so this is wild. This is wild. Okay. Okay, you know what? Hey, we're all allowed to be a little surprised. Now, where did that video go? No. I do want to watch this, but it's an hour long. No. Yes. I am so confused right now.
Function are actually then the responsibility of its callers. So the relationship between state modules and logic modules is strictly one way. State code can call into logic code, but not the other way around. As for the state modules, each should protect its private state, and state modules should only directly touch each other's public interfaces. In other words, the modules should be encapsulated. And even though logic modules have no state to protect, they too should distinguish between public functions and private functions so as to minimize exposed surface area.
Girl, you know, I'll expose that surface area. You know, these are all good tips. I am appreciating everything he's saying so far. I feel like it's pretty, like, no one can argue with as of right now. Do we got any arguers? This all seems good. No touching privates. Don't expose yourself, you know?
Now, you might object that modules might sound like objects, but there are two key differences. First, there's no rule about how big modules are allowed to get.
Well, there's no rule about how big an object can get, okay? You know, there's plenty of big objects out there, okay? I don't know why this guy has to be upset that statistically larger objects are a problem.
They may be tens or even hundreds of thousands of lines long. Very large modules.
Okay, that's too long. A module better not be. If I walked into a file that was a module that was 100,000 lines long, I'd have plenty of questions. I'd have a lot of questions at this point.
Modules are perhaps not ideal, but I'm not going to give you any hard rules against them. Second, a module is not an instance of a data type. In almost all cases, our state modules are singletons, and we're unapologetic about it.
I don't like the word singleton. Singletons almost always exist in such a way that they make me cry. Singletons make me cry every single time.
In almost all cases, our state modules are singletons.
I was just making sure. Do you at least apologize for it?
And we're unapologetic about it.
Oh. That got me. Okay. Oh my goodness, this is an Arch user convention. I can tell right away.
Data types, in fact, don't really belong to any module. The best way to think about data types is that they live outside all modules, and when data is transmitted from one module to another, the structure of that data belongs to neither module more than the other.
Okay.
We wouldn't say that a protocol belongs more to a client or more to a server, and the same should go for data types.
Okay, reasonable.
As a practical matter, though, a data type must be defined somewhere in code, so we generally define a data type in the module where it's most predominantly used. We may also sometimes want to...
I think I'm misunderstanding the term module here. I think what he means by a singleton and modules is that, you know, like a file filled with functions and data type definitions, that itself is a singleton, which I would agree with. It'd make no sense if you had instances of modules. Is that what he's trying to say? I feel like that. I feel like that's what he's trying to say. Huh.
Encapsulate operations on a data type, in which case we'd put the data type and those functions in the same module.
Yeah, it's a unit of scope. I agree with that. It's just a unit of scope. It's just a unit of scope, and it by definition it better be a singleton, or I'd be confused.
Because state management is an ugly problem, the general goal in any code base is to minimize the proportion of state code. As much as possible, we want to punt code from our state modules into logic modules. In some programs, state management may inherently predominate, but in many cases, the state code can be a small fraction of the whole code base.
Is that true?
The question that follows is, when should we break up modules into smaller modules, and along what boundaries? For state modules, a major reason to break them up is to divide and conquer state management. For either kind of module, we might also break them up simply for organization.
Yeah, see, I don't really divide my modules by any of these. Do you know what I mean? Well, I mean, like, I organize it by concept. Like, I wouldn't want to organize it by team. That seems confusing. I wouldn't want to organize it by organization. I'm not sure what it means to divide and conquer state management or to publish an API. Like the public API you could imagine is in of itself its own, repo module, however he's defining it. But I mean, I tend to always organize my modules or see, the problem is I think I don't understand what he means by modules. I think this is the fundamental problem here. I always organize it by concept. You struggle with splitting modules? I feel like modules are very naturally together, or they're very easy to do the right thing. A couple minutes after this, here's another great example. Hold on, Picky.
All code concerning feature A goes into module A, and all code concerning feature B goes into module B, etc. Such structuring can make the code base easier to understand if done well. Just be careful not to overdo it.
Yeah.
We also might split up modules for the sake of team collaboration. Group X takes ownership of module X, Group Y takes ownership of module Y, and the modules are coupled only through their public interfaces. Even for logic modules, this can help because it allows one group to change internal implementation as long as the public interface remains unchanged.
Still seems weird, like, I'm going to draw the line based on team's responsibility. Because there's plenty of places that are like, there's like in-betweeners. You know what I mean? There's things that exist in between that just. I don't know. I have a hard time with this whole organization, collaboration, teams business.
For similar reasons, we might split up modules to better formalize an externally exposed API. We don't want to bother our external users with details that don't concern them, and we want freedom to change what we've kept private. Again, many people today accredit these ideas to OO, but the ideas actually predate OO and don't require us to follow the rest of its prescriptions. We should not conflate modules with data types, and we should not obsessively whittle modules down to tiny sizes. So yes, though I spent most of my earlier videos arguing that OO sells an overly aggressive form of encapsulation, I think encapsulation is actually a perfectly useful idea. What then about?
I'm actually fine with smaller modules. I've never thought of a module as being big or small. I don't know, this whole talk, I swear we must be miscommunicating, because this whole talk, like, I never really think of size or any of those things. I do agree that, like, having a singular data type in a singular file sometimes is super annoying. Like, when things get, like, when you go into, like, a utils folder and there's, like, 900 files. It's, like, that's really hard to work with. And so I understand, but then the inverse of it, which is one file in a utils.js, a utils.rs, and it has like 900 functions in it, then that's also hard. Utils is a code smell. The problem is that that statement is a statement that exists outside of practical work. It just does. It just always does. In the end, you have some stupid thing, right? Like, okay, let's just take this. You're working like on Puppeteer. So Puppeteer, when we were writing the integration with televisions, if you don't know, I helped build part of that, which is like you have the C++ side, the actual controlling of the V8 engine or other parts of, say, NRDP, the television app, and then the JavaScript side. And one thing we had to do is we constantly had to do these weird promises, right? So it's like promise that, hey, I'm going to call this function and then I'm going to resolve this promise, but I had to like resolve it later. I had to like API it. I had to do something kind of weird. And so what I'd do is I created a function called explode promise that would return the promise, the reject, and the resolve. So that way you could have access to any of those, and then you could store that, and then say a minute later when you've done the actual thing, which could be a series of steps, I could then resolve the promise that I handed back way earlier. It's a pretty typical thing if you do like async request queues, anything like that. You kind of have to explode out a promise. And so that function is just, it doesn't live anywhere. It has no like home. And so it makes no sense to have it anywhere but like in a utils folder, Yeah?
Polymorphism and inheritance. My take on polymorphism is that interface types, or type classes or traits or whatever semi-equivalent in your language, they can be extremely useful. Their utility, however, is primarily across module boundaries, particularly across the boundary between an API and its consumer.
I like interfaces. Interfaces are great. Well, traits are great. Homeless folder, yeah. Traits are great. TypeScript interfaces are the actual worst out of all things. TypeScript interfaces are by far the worst convention ever. There's two things that are super wrong with TypeScript interfaces. One, you can define props. I do not think properties belong on interfaces. I think somehow that just feels really, really wrong. Number two, you can effectively add stuff to an interface later on. You can just like add a method. I can just take a known interface and create another method on that known interface, interface merging or whatever it's called. I just think those two concepts, like TypeScript interfaces, are by far terrible. I'm not the only one. Surprisingly, this is where me and the other TypeScript chads actually agree. Types are just better. I don't think you should be using interfaces. I don't see a point in using interfaces. I don't see what you get out of them. It just seems wrong. Like properties is definitely wrong. Properties are definitely wrong. They're crazy. But you can use them like traits. No, you can't. You fundamentally cannot use them like traits. Traits, you can use traits like interfaces, but you cannot use interfaces like traits. Because traits are they're just different, They hit differently. The trait system just hits differently. Like the fundamental concept of being able to say like, hey, here's a function and it's defined, and if you have this, you get it. But it's also, there's nothing that explicitly has to implement that interface. You know what I mean? Here, I don't think you guys understand that thing here. Let's get out of Chad stack. Here, Rust TypeScript here. This is what I mean by that. Is that I hear interface area. Nothing in here like circle doesn't have to implement area to be considered an area, right? So if I take a function, calc area, I know, even though this is stupid, right? Item implements area, right? I can go in here and go item area. And circle, though no intention of actually implementing the interface, just due to how it works, the old quack quack typing, I can go new circle. And I don't know, what's my interface on circle? Okay, go, complete it. It just works. There's nothing that, like, it doesn't, it's not doing the thing. The thing is not doing the thing. You know what I mean? Yeah, I know that's how Go works. I'm not necessarily the biggest fan of that. I still think how the trait system works is just a better usage of interfaces. I like the explicitness of it, that for like, so in the Rust world, you'd have the, do I have that around here? Dude, I don't have it. You have to implement. There you go. Here's a trait. You have to implement a display. So you have to implement the traits you want for the type you want. And that's really important. Whereas you can't just simply have an implementation that happens to have the same names for things. It has to be, I implement this thing intentionally. And then there's a lot of other really great things. Anyways.
With these interface types, we can formalize commonalities between different data types, including data types defined externally to our own code. Much like a protocol allows us to treat clients, servers, and peers like swappable components, interfaces allow us to interoperate with code that hasn't yet been written. If, however, I have no need to allow for such external extensibility, I generally avoid interfaces. An interface requires me to speculatively generalize, to imagine needs I don't concretely yet have, and this extra burden does not always pay off. For internal business, for modules well contained within my control, I don't really care about that kind of extensibility.
Sometimes it's useful. It can be, again, operating with interface, always using interfaces, it can be very useful. Obviously, that's just like saying types, right? Interfaces and types in TypeScript are virtually the exact same thing. There's a few key differences, but feels approximately the same. I like defining my types. I don't mind defining interfaces. I don't mind doing any of those things because I think it's really, really useful to do that.
Code I control, flexibility is maintained by favoring the simple solutions to my concrete problems rather than entering the realm of speculation. Now, as for inheritance,
I do agree with that, like the sentiment, or I understand the sentiment, which is like, don't abstract things that don't need to be abstracted. I do find that that's like super common concept, especially in JavaScript. JavaScript is the world of abstractions, and people abstract. They reach for abstracting as the first tool to implementing something.
Inheritance is also a mechanism for expressing the commonality between types, but inheritance additionally shares implementation. A child type automatically shares the implementation of its parent, except for those parts the child overrides. This implementation sharing might be convenient in some cases, but as famously noted, it tends to make code fragile. Changes to ancestor class implementations can affect descendants in unexpected ways, sometimes leading to some pretty nasty bugs.
I generally hate inheritance, but I always think of one thing that I really like about inheritance. And the one thing I always think about is event emitter in JavaScript, right? To be able to have a class that also has an event emitter, I think is really, really, really amazing. So if I had, extends event emitter, right? I always, for whatever reason, this indenting is insane, but I always really like event emitter, because then when I get a circle, right, const circle equals, take that, put it up here, bump up, put it in the middle, put that right here, being able to emit, right, like that as a thing, I fundamentally like that. And, maybe one could say it could be implemented without using extends or inheritance, and you could, especially with that blanket implementation via trait classes, you could get something where maybe you only have to implement a subset of this, but I like the fact that I don't have to implement anything. Yeah, exactly. There are reasons where inheritance is really good, and I'm not one of those people that just simply hate inheritance for all sakes. Like, creating something like an event emitter in Rust is not fun, because you can't just quite do that. It's not quite.
On the other hand, where types have lots of overlap in their data, inheritance makes these overlaps in code clear and more convenient to write in the first place. This is something I think the Go language gets right. A type can inherit the data of another, but this embedding, as they call it, does not create a subtype relationship. So that's actually all I have to say about how to structure code. I think it's a relatively simple picture overall. I'll end, though, by elaborating on what I think this implies that OO gets wrong.
Okay.
As already discussed, OO conflates modules of encapsulation with data types. Second, OO is overly optimistic about how frequently and easily we can create good abstractions.
I would agree with that. This modules and data types, I don't know. I still think, there's a series of data types that fit within a module or an idea that just makes sense, and they kind of go together. And so I don't really understand the separation of modules and data types. Now, like, I agree we shouldn't have, we shouldn't break every last thing up ad infinitum, but, there should be some level that makes, I don't know.
And third, OO favors design with too many small pieces. So about the second point, the underlying premise of OO is that more abstractions are always better, and that we can create good abstractions in the normal course of application development. This is wrong.
I would agree. Fundamentally, I agree with that. The idea that it's that we talked about this yesterday. This idea of that I'm going to abstract my code because there could be this case that I haven't thought about yet. Therefore, because I have not thought about it, I know it could exist, so let's design our system to be able to handle some future case. That is probably led to more heartache and more upsetness than I think anything I have ever had in my lifetime. It's just that, because it's so frustrating. It's so dang frustrating. It always ends up being this cluster festival that just didn't need to exist, because it turns out you never actually extended it beyond anything basic. And so
Good abstractions take a lot of hard thought and time to get right, and typically they emerge only slowly over many iterations. Now, when creating an API, creating good abstractions is part of the job. Hence, creating a good API can be very difficult. In normal application code, however, we should free ourselves from this burden where it's not truly necessary. Cases do arise where new abstractions provide better solutions, but our default mode should not be seeking to create new abstractions. As for the size of our code units, the difference between procedural and OO is how and when we subdivide the units. In procedural code, we modularize by accretion, only splitting up modules when they get too unwieldy. In object-oriented code, however, we modularize speculatively, splitting up modules in anticipation of problems later. In theory, OO code is flexible. We create a bunch of small independent pieces such that system behavior can be changed by reconfiguring the connections. But in practice, the burdens of speculative generalization rarely pay off.
I agree with that. I mean, the thing is I actually do such a different version of starting off. So like I have this whole theory where whenever I start a new project or I start something new, I start in a single file and I just start dumping things in until I find a good reason to change it. So like I have this whole search thing that I've been building at Netflix for some data, and it just takes a bunch of different sources and then does like an extra step of data processing underneath the hood. And so I started with just like one file. I just wrote it yesterday and today. And I just wrote it out, just making it all happen. And I realized, okay, there's really like two parts of this. There's like the building of the request, because I want to be able to request these data to a service. And then the handling of a request. Now that I have data plus the request I want to make, how do I do it? And so it's kind of like these two sides. And so it became a very obvious, natural splitting of the like the modules, right? And so for me, that just made perfect sense. That's just how I wanted to see it. That's how I wanted to do it. But I didn't start off knowing that. I just simply built it out all in one file until I felt like, okay, this is the time I need to abstract. This is the time that I feel like I see two separate things developing. How much code do senior engineers actually do? I write a shit ton. I write a huge amount. That is my job, to write a lot of code.
Structure is about a thing's relations to other things. But
my team is a heavy code team.
Piecemeal tiny units in isolation. The pieces produced in this process might be easier to build and understand individually, but the whole system is not.
There's like no architects. We just don't have architects. Architects are the ones that go around in lab coats telling you how you should write your code, and it's very fantastic and it's very beautiful and it works perfect on a whiteboard, but when it actually comes time to implement, it's horrifying and awful. I don't like architects, okay? I don't want anything to do with architects. I've never had a good experience involving an architect. I swear every single time, it's always just awful.
Meaning requires context, and these tiny units are isolated from context. Object-oriented design is often sold as the responsible thing to do, the moral equivalent of keeping a closet or drawer meticulously organized. What typical OO designs feel like, though, are tangles of excess packaging.
Look at that little guy. Poor little guy. Who architects then? Everybody architects. Everybody does architect. Like when you build out your piece, you architect. And when some piece needs to be larger and put together itself, and we have like a larger constraint, you have to go and get a couple people together and all agree on it. That makes way more sense. Like when, okay, I want to rechange like the program of how say startup works, or where our main is how do we link with partners and partner televisions. Well, somebody does the research, comes back and says, hey, these are the ways I want to change it. And then you can get a group of people on the team go, yeah, I like these changes. I think these are good. I don't like those changes. I don't think those are good. And then they go back and they kind of make some changes or what they think is good, and then kind of come back and argue for it. So like each person becomes the own architect of their own area, because there is no reason to have somebody that only thinks of architecture. I really don't understand that. I think that architects, if you purely do non-coding architects, you do not at all You can't contribute to a project reasonably, because every month that goes by you're not coding is every month you don't understand how production works. And as that gets further and further from your understanding, you just simply start suggesting these things that are just stupid, and it feels good because it looks good on a whiteboard. It always looks good on a whiteboard. Every piece of code looks amazing on a whiteboard. Just like my brain, when I come up with this new greatest idea, everything is fantastic, and then you implement it and it's horrible. It just was wrong. Everybody is an architect. That's the thing. Everybody's an architect. Whenever you build code, in some sense, you're architecting it. And as you get more experience, you can build larger pieces of code that fit together. And that's really it. That's how I look at it. Chat stack looks amazing on the whiteboard. Yeah. Don't mock boxes and lines. I will mock the crap out of it.
Everything is so fractured, indirected, and abstracted that, like in Wonderland, nothing in code is as it seems. The names of the classes and methods lie about what they actually do, because the real work is always done elsewhere. The procedural alternative, comparatively, encourages us to introduce abstractions only when they're much more likely to be useful.
Go subscribe to Brian Will. Good guy. Good guy right there. Good guy. That was a good one. I like it. Here, let me finish it off. Finish it all the way through. You know, all the way through. There you go. Perfect. Yeah, that was good. Yeah, there wasn't, you know, this was a really good video, but I don't really know what it has. You know, it's hard to take anything concrete out of this video. It was good. I appreciated it. I'm going to give him a thumbs up.